We're going to be talking about the MongoDB shell, a primer. My name is Rick Golba, and I am one of the solution engineers with Percona. If you've been on a call with one of our sales folks, you may have had a call with me as well, because I'm on a lot of those calls. And I will be starting off with this, and then we'll be turning it over to Adamo for a little bit, and throughout the rest of the day. So it's kind of funny, when I was asked to do this presentation, and the title is a primer, and of course this is a 101 presentation as well, I looked at the example of what they were saying and I said, a primer, huh? How many of you have ever driven a stick shift? A car with a stick? Yeah. You know, you get in the car, nice normal day, you're in first gear, second gear, third gear, fourth gear. Now you get on the highway, so fifth gear. Life's good. That's kind of a primer. The other possibility is you're getting onto the highway, and you're like first gear, second gear, third gear, fourth gear, fifth gear. Guess which one we're doing? We're doing that one. We're going to start out really kind of basic, and then we're going to get into some more involved things. So the Mongo shell. What is the Mongo shell? It's a JavaScript interface that allows you to work with MongoDB. Is it the only way that you can do a lot of these things? No. You'll see that in the next presentation, as a matter of fact. But it's one of the ways that you can do a lot of things, and it certainly is a nice, easy way of just kind of trying some things out. Part of the standard installation of Mongo, and that holds true if you're going with Mongo Community or if you're looking at Percona Server for MongoDB. The shell is one of those things that with Percona Server for MongoDB, which clearly needs a better name, because it needs to be much shorter, it's one of the things that we haven't changed in any way. So you're not going to find that there are new features in the shell because you're using the Percona version of it. It's the same shell. And you can see some of the things that you can do with it. And the one thing that just to always remember is by default it's in user bin. So you're going to want to add that to your path so that you can just type in Mongo and get into the shell whenever you need to access it. A couple of the common options that you might find yourself using when you are starting up the shell. You can see the various possibilities here of what you might want or, in some cases, need to specify. I've actually, in my past life, I was a software trainer, and the worst experience I ever had was knocking a client's 65-inch plasma screen onto the floor because I tripped over the power cord. So I have been known to be a bit of a klutz. Hopefully we won't have anything like that happen today. If it does, feel free to laugh, though, because it's okay. So by default, when you install Mongo, it's going to listen on port 27017. If you've changed that, then that's something that you're going to need to specify when you're starting up the shell so that you're telling it where to listen. You can see the host name information there. Again, this is important if you're not running on the machine that actually has the Mongo service installed on it. A lot of the sessions that we've had here, we've given you some virtual machines. I know I did the Mongo 101 tutorial on Monday. We gave a virtual machine. In that case, you're working on everything right there, so you don't have to specify any of this stuff. But certainly, if you are remote from your server, which most of the time you are, you'll want to do that. And then username and password if you need authentication to get into the Mongo environment. And with the password, just two comments. You can obviously put in the password there, but realize it's clear text, so it's a little unsecure. So the other possibility is to actually use the password option, but not provide it, and then the shell will just prompt you. And then, of course, help. Always good. So let's talk about some of the things that you can do within the shell that kind of take you beyond some of the more basic stuff. Just to kind of give a little landscape here, with MongoDB, we're creating a database, which is the equivalent of a database in MySQL. Within that database, we're going to have one or more collections. And that's where we start to diverge a little from what we know from MySQL, because the equivalent of that in MySQL is going to be a table. And then we're going to have a series of documents. And those are the equivalent of records now in our MySQL world. So we're kind of going in the assumption here that we've got our database, we've got our collection, we've got some information in there, and we want to do something with it. And with regards to the query syntax that we're using, you can see a little bit of the beginning part of that syntax there with the db dot, the name of the collection dot find, and then you'd put in your criteria there. One of the things that is a peculiarity of the shell is that when you are running a query in the shell, if it finds, let's say, 300 records, it returns them 20 at a time. And it has the most bizarre statement at the bottom. It says, type IT to show more. And I'm like, type it? It actually is iterate. So it will show you another set. I don't know why more didn't come to anyone's mind, but it didn't. It seems a little obvious to me. But one of the other things is, if you're looking at something where you know you're going to get a huge number of results back, but you really don't need that huge number, you might want to just control it. You might want to say, you know what? I only need to see 10 of these. I just need to see a sample set. You can use limit in the query criteria there. And you can see that that takes a number as the argument there. And that's just going to limit down the number of records that you're going to return. Again, lots of cases you're not saying, do I need to show them all? You just need to show that the query works and is returning what you expect it to return. A lot more efficient, allows the queries to run faster and obviously get you where you need to. And then the other option that we're talking about here is the idea of skipping certain numbers of records. You might say, I want you to return 10, but I don't want the first 20 for whatever reason. I want you to go a little deeper down. So you can use the skip option in there as well and specify the number of records that are going to be skipped before you actually start returning any data. Sorting. Like a lot of databases, when you do a query in Mongo, the results don't come back in any fashion that is sorted. So if you do want to sort your data, you're going to have to include that into the query. And you can see, again, .sort, and then the syntax that you follow there. You can do multi-level sorts. The sort is always what key, equivalent of a field, in Mongo you're using for your sort, and then either a 1 or a -1. If you specify 1, it is an ascending sort. If you specify -1, it's descending. The one thing, again, like a lot of databases, be very careful of sorting. If you don't need to sort your data, realize the overhead that it's putting into your query. Now, if you have the data indexed, it can be faster, all those things. But one of the things we're going to look at in a little bit here is an explain plan. And you very likely may see a sorting step in an explain plan, particularly when you get into multi-level sorts. So just be aware of it. Again, I don't feel that that's any different than other databases, but something to just keep in mind. Yeah. Yeah, and it'll return them in what's natural order, so the order that they are in the collection. So now, we get into some of the fun stuff. The MongoDB aggregation pipeline, and I will tell you, unfortunately, this was yesterday, but there was a 30-minute presentation on this topic alone yesterday. So obviously, it's something that could be discussed in much more detail. But one of the things that you want to think about is when you have a query that may require multiple steps, how is this actually all going to be processed through? And we're going through a fairly simple example here, where we're looking at doing a match, so we're looking at limiting the data that we're looking at, and then we're looking at doing some sort of aggregation, in our case with a group by. But like I said, there are several different aggregation operators that you can use in here. So what we are doing with this query is we are looking for customers that are active. We've got a couple that are active here. We've got one that is inactive. And then we just want to get the total amount that each customer has spent with us, but only for our customers that are active. Now, in this case, we have two options. We could go through and we could say, okay, let's find all the customer IDs. We've got 412, 412, 412. We could add all the amounts together, and then we could look and go, oh, wait, this one, we need to take it out. Obviously, that's pretty inefficient. So the aggregation pipeline is smart enough to know that the first thing that you should do is apply that match criteria. So it says, when I apply that match criteria, I ignore that document that doesn't match to my criteria. Again, we're showing 4 documents here. Woohoo, we saved 1. But imagine if we're talking 400,000 and we just got rid of 100,000 documents or even more. The orders of magnitude of power and processing improvement that you're going to get out of this can be really huge. So then the next thing that we'll look to do is the group. And for that, that's where we're going to go. And we're going to sum the data only, again, on the documents that actually match to our criteria. And again, one of the really cool things about this is, if you wrote this query wrong, and I put it in air quotes because, there's no wrong, there's just not right. But if you swap these two in order, so you had the group first and the match second, in the process of planning out the query, Mongo is going to say, I know what I should do. I'm going to do the match first, because it's going to make it more efficient. Obviously, again, that's another step of processing that Mongo needs to do, and I'm a control freak. I like being in control of all this stuff and knowing exactly how it's going to go. So if you can get the queries structured in the right way, so much the better, but know that Mongo will have your back, which is always a good thing to know. Mm-hmm.
If you do have it set up in the correct way, or in the order that you want it, will that bypass the extra step that Mongo would have to do to check if it is in the right order?
It does, yeah.
Okay, so it would save you to get it. Okay.
Yeah. But it's kind of like that fail-safe that says, I got you no matter what you do. Yeah.
So you're buying something wrong inside the last where is the you buy, I think missing something, right, the last one. Is that right?
That we're not processing this record?
No, I mean the buy, the query. You have double code like customer ID. Is that a code that should be double code? Doesn't make sense to do that.
Oh, yeah. I am. You're right. There should be a close quote there. We'll get that into the PDF version of the slides. Thank you. Mongo says, that was you. And notice it was you. It was not me. But yeah, in this case, the query would actually fail. You are correct. Yeah. And darn it, I remember catching this a couple days back, and I thought I changed it. And there's our result. Another thing that you might want to look at is an explain plan, just to see what's going on during the processing of this query. And you can see the syntax for pulling up an explain plan on a Mongo query here is that you put explain and then the method in there. And you can see that there's going to be a series of operation types that you can get explain plans on. And it's going to help you to figure out if there are ways that you can make the query run more efficiently. I mean, one of the big things with Percona, you're not allowed to answer this, John. Does anyone know where the name Percona came from? It's actually a combination of 2 words, performance consultants. And then we threw an A at the end just because it was not sounding good up until then. But one of our things is looking at ways of making your environment run better. And this is one of the big things that we're going to use. This is one of the things that you can use. This is going to tell you exactly the process that it's going to go through, that Mongo is going to go through to resolve this query. It's going to tell you the possible paths that it explored, and it's going to tell you the one that it's chosen. Now, the fact is, the one that it's chosen is the one that it deems to be most efficient. That's not to say that you can't optimize another one of the paths to make it even more efficient so that now your query is going to run faster, better, and get you your results in a much less impactful way. So doing explain plans is great. I will tell you, trying to get all the text of an explain plan on a slide, it just didn't happen. It's not going to fit. But some of the stuff that you're going to see in the explain plan here. These are a few of the concepts and terms that you might want to just kind of keep an eye out for. The first one is a call scan, which is a collection scan. If you see that, that's the equivalent of a full table scan. It says, I got to go through the whole collection and find this information. You've used some criteria, and we don't have an index that we can use to help us find that data. So we had to go through the whole collection. Probably not the most efficient thing. Instead, if you can see an IX scan, an index scan, that's probably going to be the faster option of the two here. And again, it will tell you all the indexes that it considered, the index that it chose. It will give you all of that information. You'll see any fetch activity in there for when we're actually going out and retrieving the data. And of course, one of the other big advantages of Mongo is that it is inherently capable of doing sharding in a much easier way than a lot of other databases out there. And so if you have a sharded environment, you'll see the shard merge. If we have to go out to various shards and gather information from them and then merge them all together. One of the things about sharding, and we talked about this in the Mongo 101 that was on Monday, and we'll talk about it more throughout the course of the week, is if you are going to do sharding, making certain that you're picking a good, solid shard key. In the 101 class, one of the questions that came up was, well, if I'm sharding, for example, by state, anyone think state would be a really good key for sharding in MongoDB? Nah, it's probably not real good. Because the first question that came up was, well, what happens if the person lives in California and then they move to Tennessee? Guess what? We have to get rid of their original record and create a new one. And then we look at it and we go, you know what, this really was a bad decision. We want to shard by something else. What do we have to do? Dump the whole collection and import it again. So picking a good shard key is really important. And one of the things here with this idea of shard merge means that we needed to touch more than one shard in order to run this query. If sharding is working really well and if your queries are working really well, and I mean, I'm not saying this is a requirement, but this is the best of all possible situations, is that we are able to say that shard has all of the information that I need in order to process this query, returns it, no merge needed. We got all the data. So if you see a shard merge in there, you'll be able to tell that there was a need of touching multiple shards. One of the other things to definitely be aware of with Mongo is the write concern. When you're dealing with a replica set, and again, in most cases with Mongo, people are looking at running replica sets. The norm is to say, I need to write to the master and get that acknowledgement back, and then I'm good. And then there will be replication to the secondaries. That's a wonderful process, and it works really well. It's very efficient. It gets the writes processed very quickly. But it can cause you some problems if you're running your queries off of the secondaries, because you don't know whether that secondary has had that document replicated to it. And that document might be a document that you are supposed to be returning with your query. So with the write concern, we can start determining how it is that Mongo is going to handle all of this. So in this case, you can see that we have a query here. And anyone who was at the tutorial on Monday, we did some work with movies in there. But you can see that this is a query to insert a record into a movies collection. And in this case, we have specified a write concern of 2. Now this is assuming, I shouldn't say that, I assumed a replica set of 3. So what that means when I say write concern 2 is getting a write acknowledgement from the primary is not sufficient. I must get a second acknowledgement before I can actually acknowledge the write to the application. You can specify a write concern as a number. You can also use the word majority. And as you know, if you use the word majority, it's got to be in those double quotes. So this is an example of write concern 1, and in this case, because we're dealing with a 3 node replica set, a write concern of 2. In the write concern of 1, you can see that coming out of the driver, we have a write that's coming into the primary. The primary says, I was able to apply it, and I send the response back out to the driver. It's all done. And then replication takes place, hopefully quickly. No one in this room has ever had replication issues with the database, though. So you know that this all goes smoothly. Exactly. So in this case, the replication is taking place, we hope quickly, but we don't know when. And if, again, you're querying directly off of one of these secondaries, you may not be getting the most up-to-date information. That may also be completely okay. If it's something that you're looking at and you're saying, yeah, how many people have signed up on our website? Does it really matter if it's 4,903 or if it's 4,905? No. You probably just want to know it's around 4,900. That's probably good enough. So in a situation like that, having a right concern of 1 could be fine. But if it's something where you do need to know that you're getting the most up-to-date information, you might want to look at a different right concern. And this is expressing a right concern of 2, or we could use majority in this case because we are dealing with the 3-node replica set. We have the right coming in from the driver, being applied to the primary, being replicated to one of the secondaries and applied. And only upon that second application can we acknowledge back to the driver that we have actually completed this write request. Now there is still replication to that other secondary, so there's the possibility that now that secondary lags a little behind. Maybe this is the one that you use to find out how many customers you have, and this is the one that you use to find out how much money they've spent with you, because that might be a little bit more important than the number of actual customers that you have. Okay with it? We have some aspects of control over that because we have priorities on these, and we can specify through kind of a background way how we're going to get that to happen. So yeah. And then, of course, through the drivers, we can specify which secondary it is that we're using to run our queries against. So that can become an important thing. Right. Right. And again, that's one of the reasons that you might go with majority over an actual number. Because the situation where you have a secondary that's down can cause you a lot of grief. If you have a 3-node replica set and you've specified 2 and one of your nodes is down, well, you need to get acknowledgement from, hopefully nothing bad is happening from what I'm doing with my fingers, but you're getting an acknowledgement from those 2. That's okay. And actually, majority would have done the same. But what if you have 5 nodes and you've specified a write concern of 2? 2 nodes are down. You still need to get write information from these guys. If you just specified majority, it's easier. So you say, I got to get it always from a majority, because now in the 5 node with 2, you got to get it from all 3. It was math. It took me a moment. I was an English major. It takes me a moment. Whoop. So one of the things that is possible out of this is that your secondaries can be a little storing data that's a little different than what's on your primaries. So Mongo provides this validate command that you can use to go out and compare the data that is on the primary and all of the secondaries. The important thing to note on this one is that this can be slow, particularly if you have a really big data set, because we're going through and we're looking at everything and saying, do we have the same number of documents here as we have on this node? Are they structured the same? Is everything looking like it's all been processed through? But this is one of the things that you can use if you suspect that there are some issues with replication out there. You can see the syntax, DB collection validate, and then you would use true to get this to actually process through. And this is a brief summarization of the output that you're going to see in there. The full namespace, the number of documents in the collection, and the number of indexes, the number of keys in each one. And you're going to get this for each one of your nodes. So you're going to be able to look at this and say, well, node 1 has 4,003 documents on it. Node 2 has 4,008 documents on it. There's something that's amiss there in that case. So it just starts to point to potential problems. Does it tell you this is the problem and this is the fix? No, but it gets you to that point where you can start figuring out that something is going on in there. If you have errors, you're going to see those showing up in the validate errors field here. And then, of course, the last thing is the OK, which is just going to tell you yay or nay, it was successful in terms of completion. In addition to your write issues, you also have some issues with reads in Mongo. And it's the idea of determining where you're going to be reading data from. And this is going to be our read preference now. And this is going to allow us to determine where it is that we're going to look to when we're doing any read requests. So you can see that by default, we're going to read from the primary. If the primary is unavailable, what happens then? Well, an election happens, and then you're going to get a new primary, and it's going to go through all that. But yes, you do have to just bear that in mind. What if you want to read while that election's taking place? Primary preferred. Hey, I'd like to read from the primary, but if I go there and it ain't there, and I was an English major, then what happens? Now we're going to look to a secondary. Even though we preferred to read from the primary, we can and we will look to a secondary. We can specify a secondary as the place that we are going to go. We can also do secondary preferred, saying try to read from a secondary, but again, if there's no secondary, you can read from the primary. And then there's an option to read from the one that is physically closest to you. And this can become really helpful when you have geographically dispersed nodes, and you just want to read from whichever one is closest to you. There's a staleness option that you can set in here that is determined in seconds. And it says, so if I go out there and I find out that this is more stale than, by default, something greater than 90 seconds, which means you're pretty far out of sync most likely, then we're going to actually look to the other options other than going to primary in there. And you can specify this through your drivers. You can specify this within the actual query itself. So you can determine how your reads are going to process to in Mongo. So that you can keep track of where the data is being written to and how consistent that is. And if you have, like I said, the query that is looking to say, how many customers do we have that signed up on the website? You might be looking at secondary preferred on that. How much money have we generated? You might be looking at primary for that because that's a little bit more important to you. Questions about any of that goodness? Yeah. So the question was, if the primary is unavailable, is there a way to specify that you want the most up-to-date secondary to be the one that comes through? That's going to be more about the election process and how that election process is going to go through. And with that, you can set a priority in terms of the prioritization of the secondaries as to which one becomes the new primary. But remember also in 3.4, even if we make a secondary the new primary and that secondary is not as up-to-date as another secondary, Mongo can actually update from that other secondary to the new primary. You'll need to think about that one for a little bit because it takes a while. It's a weird little thing because it's like now we've got replication from a secondary going to a primary, which is kind of odd. But
So he knows that Java has like a origin data.
yep, that is smart. Or as Bostonians say, that's wicked smart. Alrighty.